Hello and welcome to Mr. Tompkins EdTech and a brand new series of videos aimed at helping you prepare for your GCSE mathematics exams. In this series I'll be giving a complete walkthrough of the GCSE mathematics practice papers to help you prepare for your exams this summer. Now there are not so many of these and you don't want to squander them, so make sure you try the paper yourself first before you look at these solutions. This particular video is AQA New Practice Set 1 Foundation Tier Paper 3 Calculator. Check the front cover of your paper to make sure it's the same one. If it's not, have a look through the playlist linked above, which includes all the GCSE Maths video walkthroughs I've recorded so far. I'm busy recording all of the GCSE practice papers, so if the one you're looking for isn't there already, why not subscribe by clicking the big red button below and check back in a few days. Don't forget to click on the bell so that you'll get a notification when I upload the next paper. I'll put timestamps in the description below, so you can choose to watch the whole thing through, or you can click on the timestamp and jump to the particular question you need help with. If you have a question, check the comments below, as someone else might have already asked the same thing. If it's a new question, leave it in the comments and I will try and answer all of them as soon as I can. Don't forget to mention which question on the paper you're referring to and try and be as specific as possible. Finally, if this video helps you with your revision, please give it a thumbs up. It will really help me out, and why not share the link with your friends, because they might need a helping hand too. Okay, let's get into it. Question 1. Circle the decimal that has the same value as 4/5. Well, these are decimals out of tens and hundreds, so if we can convert this fraction, so the denominator is either in tens or hundreds, we should be able to compare them. So 4/5 I can turn into a fraction over 10 by multiplying top and bottom by 2. 5 times 2 gives me the 10, and 4 times 2 gives me 8. So 4/5 is the same thing as 8/10, which has got to be the same thing as 0.8, because the digit after the decimal point is tenths. So 8/10 is 0.8, which is that one there. Question 2. Circle the word that describes the straight line PQ. Well, that's a chord. It's one of those questions you either know or you don't. There it is. Question 3. X is 2,500 to the nearest 100. Circle the smallest possible value of x. So this is a limits of accuracy question. I'd like to set these out with a scale. So imagine a scale with the number that you've been given in the middle of it, 2,500. Now this scale is going up in increments of 100. So the next number up on the scale is going to be 100 more than 2,500. Which is 2,600, and one below it is going to be 100 less than 2,500, which is 2,400. Now our number rounds to 2,500 to the nearest 100, which means all the numbers that are going to be closer to 2,500 are going to round to 2,500. So if you look at the mark halfway between these, then all the numbers between that halfway mark and that halfway mark are going to round off to 2,500. So anything in there. Okay, so what are those values that are halfway between 2,400 and 2,500? That's going to be 2,450, and the other one is going to be 2,550. Now we want the smallest possible value of x. So it's going to be this one at the lower end. It's going to be this one here, 2,450. That one there. Question 4. What is 1/4 of 5 hours? Tick a box. So 1/4 of 5 hours. So that's 5 quarters, and isn't it? 5 over 4. And there's a top heavy. That's what we call a top heavy, or an improper fraction. Now converting that into the mixed number, 4 goes into 5 once, remainder 1. So it goes in once, that's a big one there, and a remainder 1, so that's a small one there. So it's the same as 1 1/4. Okay, so 1 1/4 hours, that is. Now a quarter of an hour is 15 minutes, so that is 1 hour. and 15 minutes then, isn't it? So it's that one. Question 5. Simplify 6w minus 5x minus 4w minus 2x. Okay, so here we need to collect like terms. We've got terms in w, which I'm going to highlight in yellow, and we have terms in x, which I'm going to highlight in green. Now notice I'm highlighting the sign that goes in front of these terms because it belongs to the thing that follows them. So I've got 6w and negative 4w. In other words, 6w take away 4w. That's going to leave me with 2w. That's what I get from the yellow terms. And I've got minus 5x minus 2x. Now if you're at negative 5 on the number line and you take away another 2, you're going to be at minus 7x. So the green terms combine to give me minus 7x. So altogether I've got 2w minus 7x. Question 6. Beth uses these 4 cards to make 4-digit numbers. How many different 4-digit numbers can she make that are greater than 8,000? Okay, Beth, what are you going to do here? 2, 4, 5, and 8. So we've got 4 places to fill. Let's think about what choices we have for each of these. Now, my number needs to be greater than 8,000. So I don't have a lot of choice for the first digit. It's going to have to be this one here, isn't it? It's going to have to start with an 8. So it's 8,000 and something. If it starts with 2, 4, 5, it's going to be less than 8,000, so it's no good. Okay, so it has to start with the 8s. That was only one choice I had for that. Right, what's the next digit? The next digit could be any of the other 3 numbers. So I've got 3 choices for that one. It could be the 2 or the 4 or the 5. So let's say I pick the 2. How many choices have I got left for the next choice? I've got 2 choices. Let's say I pick the 4. How many choices have I got left for the last one? I've only got 1. Okay, so then we can work out the total number of ways by then multiplying those choices together. So 1 times 3 times 2 times 1 should give me the number of ways of working it out altogether. So 1 times 3 times 2 times 1 is 6. So there are 6 different numbers greater than 8,000 that she can make. Another way of doing it would be an exhaustive approach where you just wrote down all the various values until you had all the different ones. So 8,245, 8,254, etc. Until you got through all of them. Either way, you're going to get 6 values. Question 7. The table shows the number of Year 11 students who are absent in 1 week. That is quite a lot. You need to be in every day if you're going to do well in your GCSEs. So number of absences on Monday was 14, 13 on Tuesday, 11 on Wednesday, 15 on Thursday, and 16 on Friday. Jack uses this information to draw a bar chart. Okay, here it is. Write down 2 mistakes that he has made. Okay, what are his mistakes? Okay, let's have a look at the labels first. Monday, Tuesday, Wednesday, Thursday, Friday. So he's labelled the x-axis fine, and he's got spaces between his bars, which is appropriate. Well, kind of is appropriate until you get to there, and he's kind of squished 2 bars in a bit too close together. He's gone over he's only used a half gap there. So I'd say one of the issues is that the bars need to be equally spaced and not kind of one space between here and here, look, and only a half a space between here and here. That's no good. They've got to be equally spaced. So that's my first criticism. Bars should be equally spaced out. Okay, now let's have a look at the other thing he's done. Let's have a look at the other axes. Now you can see this axis starts at 10. Now you can start axes at not 0, but you need to use what's called a broken scale. It's like a little wibble wobble like that to show that it doesn't start from 0. And actually on a graph like bar charts, it can be a bit misleading to do that. So it's not really recommended to do that on bar charts like that. It's fine on a scatter graph if you've got a big kind of empty gap that you want to get rid of. But in a bar chart like this, I don't think it's a great idea. So scale starts at 10 with no broken scale indicated, and might be misleading. Okay. Now you could also have the fact that there's no label on the scale here. Should be labeled. Okay, so there's a label missing there. So you could have also had a mark for saying that label was missing. So plenty of things wrong with this. Question 8a. On the grid, draw a shape that is a reflection of shape A. Show your mirror line. Okay, so there's no mirror line drawn. It just says we can add one in. So let's draw a mirror line here. You have a bit of a free choice for this. Now, reflections. The easiest way to draw a reflection is to take each point, work out how far away it is from the mirror line, and then count that same number of spaces on the opposite side of the mirror line and draw its reflected point. You should do that for each of the points. So that one reflects there, that one reflects there, and you just kind of work your way around the shape. And that one reflects there, and that one reflects there. Once you've finished it off, you can then join it up with straight lines. Okay, so the key is to reflect the vertices or the corners of the shape and not the lines. People who try and reflect the lines end up going wrong at the end. So top tip. Right, so for part B, on this grid, draw a shape that is an enlargement of shape A. Okay, so an enlargement needs to be the same shape, but every side a kind of multiple of the previous one. So let's do one with scale factor 2. It's probably the easiest one to do, isn't it? It doesn't tell me anything about this, what scale factor I have to use, so I'm just going to use 2. And let's start at this point here. Okay, so let's just go around the shape. So this side here is length 2. So then if I increase that by a scale factor of 2, it's going to be 1, 2, 3, 4 units along. It's going to go to that point there, isn't it? To there. Okay. I should use a different color because it didn't come out very well last time. Let's use green to draw it in, so you can see the lines better. Then going down this way, I've got 1 square. So doubling that up, that's going to be 2 squared, isn't it? It's going to go down to there. And then going this way, it's 1 square. So on my diagram, it's going to be 2 squares. And then going down like that, it's going to be 2 squares. So on my image, it's going to be twice as far. It's going to be 4 squares. 1, 2, 3, 4, down to there. Oops. Down to that point there. And then along there is 1 square. So 2 squares on my diagram will take me to here. And then I can close it back up. Again, once I've done that, I can quickly just join it up with straight lines. All done. Question 9a. We've got a sign here. It says DVDs, £5 each. Buy 2, get 1 free. How many DVDs do you get for £35? Okay, well, there are £5 each, and if you buy 2, you get 1 free. So if you pay for 2, which is £10, you're going to get the 2 that you purchased plus your third 3 ones. So you're going to get 3 DVDs for £10 then, aren't you? Okay, so in £30, you can get our £10 giving us 3. Another £10 giving us another 3, and another £10 giving us another 3. And then I've got £5 left, and with that £5 I can buy just 1, can't I? because they're £5 each. So for £35, I'm going to get 3, 3, 3 and 1. That's a total of 10. So I'm going to be able to get 10 DVDs. Question 9, part B, says the pictogram shows some information about DVDs and the key is missing. The total number of DVDs is 260. Work out the number of sport DVDs. Okay, so the total number of DVDs in there is meant to be 260. And I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 whole ones and 2 half ones, which makes 13 altogether. So our 260 DVDs is represented with 13 pictogram DVDs. So the scale then, so I've got 13 of those, haven't I? And that's representing 260. So how many times does 13 go into 260? 13 goes into 26 twice, remains a 0, so it goes in 20 times. Okay, so that means that one of those pictures must be equal to 20. Okay, so one of these, one of the symbols is equal to 20 DVDs. So sports DVDs, you can see we've got 2 symbols and a half. So I need to do 2.5 times 20 then. How many is that then? So 2 20s are 40 and half of 20 is 10. So 40 and 10 make 50 DVDs. So there must be 50 sports DVDs. Question 10. I've got 2 boxes here, box A and box B. Box A has got the numbers 2, 3, 4, 6 and 9 in. And box B has the numbers 1, 5, 7, 8 and 10. Don't really notice what they have in common yet. Right, it says 2 of the numbers move from box A to box B. The total of the numbers in box B is now 4 times the total of the numbers in box A. Which 2 numbers moved? Okay, so I'm going to take 2 of the numbers out of box A and put them in box B, in such a way that box B is 4 times bigger than box A. Now I could just do a kind of a trial and error approach here and just keep taking 2 out and putting it in the other one until that fact is true. That is probably the easiest way of doing it, but I'm a maths teacher, so let's do it the proper way, or a proper way. So how many have we got in box A? I've got 2, 3, 4, 6 and 9. What does that add up to? 2 and 3 is 5, plus 4 is 9, plus 6 is 15, plus 9 is 24. So this one adds up to 24 to start with. And box B, 10, 1, 7, 8 and 5, what's that? 18, 25, 30, 31, adds up to 31. So together the numbers add up to 55. Okay? We're told that box B is going to be 4 times bigger than box A when we start, when we end up. So for every 1 we're going to have in box A, we're going to have 4 in box B. It's in a ratio of 1 to 4. So like taking our 55 then and dividing it into a ratio of 1 to 4, 1 plus 4 is 5. So taking our 55 and dividing it by 5 into those 5 parts gives me 11. So that tells me that each part of my ratio should be 11. So multiplying it up by a factor of 11, I should get 11 in the first box to 55 in the second box. Okay, so I need to end up with 11 in the first box and I need to get 55 in the second box. So which way round can I do that? So if I've got 24 and I want to end up with 11, then I need to move 2 numbers that add up to 13. So which 2 numbers add up to 13? Those do. So if I move the 4 and the 9 over there, I'll get my 13 left in, sorry, my 2, 3 and 6, which give me 11 left in box A. My 4 and 9 making 13 moves over to box B, and the total is now going to be 44, which is 4 times bigger than 11. Okay, so the answer is 4 and 9. Okay, like I say, you could also do a kind of a trial and error approach where you could have just selected pairs of numbers and move them over. Question 11. The diagram shows a sequence of patterns, and you can see here that we've got 3, 5, 7 and 9 circles in those patterns. Work out the number of circles in pattern 6. Well, each one we're adding 2, aren't we? This is a +2 sequence. So if I'm going from pattern 4 to pattern 6, I'm going to be adding 2 and adding 2. So for my 9 plus 2 plus 2, it's going to take me up to 13, and isn't it? It's going to be 13. Complete the rule below. Number of circles equals the pattern number times a number plus a number. Okay, basically they're asking us for the nth term of this sequence, aren't they? So this sequence is going up in 2s, so it has something to do with 2n. I'll have to multiply it by 2. And if you look at the first pattern, we've got 3 in the first pattern. So if I took the first pattern and multiplied it by 2, I'd have to add on 1 to get up to 3. So it's the pattern number times 2 add 1. Which pattern has 51 circles? Okay, so if the nth term is 2n plus 1, like we just talked about, and that is equal to 51, we can kind of solve that like a linear equation. Subtracting 1 from both sides is going to give me 2n is equal to 50, and then dividing both sides by 2 tells me that n is equal to 25, so it's the 25th pattern that has 51 circles. Question 12. In 2012, electricity costs 15 pence per unit. A family used 3,729 units. In 2013, electricity cost 17 pence per unit, and the family used 3,506 units. How much more did the family pay for electricity in 2013? Okay, so it's just a straight multiplication here, isn't it? So I know the unit cost in 2012 was 15 pence, and I used 3,729. So multiplying those together then is going to tell me, it's going to tell me what the total cost of that is, 3,729 times 15. And then in 2013, it cost 17 pence, and we used 3,506 units. So again, multiplying those two together, 3,506 times 17 will tell me how much it was in the second year. Okay, so grabbing the calculator, 3,729 times 15, that gives me 55935. It's going to be in pounds and pence, isn't it? Well, it's all in pence at the moment. I can convert it to pounds in a minute. 3,506 times 17. 3,506 times 17 is 59602. 59602. So like I say, that's going to be in pence. So if I want to convert it into pounds and pence, just need to put a decimal point in there and there. So I've got £559.35 in 2012 and 59602 in year 2013. So then the difference, how much more they're going to pay, is going to be one subtract the other, isn't it? Subtracting 559.35. Or 55935, because I haven't got the decimal point in my calculator yet. That gives me 3667. 3667. Again, the decimal point goes there, doesn't it? So £36.67 is my final answer. Question 13. I've got a couple of shapes, A and B, and underneath it says work out the area of shape A, and I've got two little dots, which is a ratio, isn't it? So it's the ratio of shape A to shape B, their areas, and give the answer in its simplest form. So we need to find the areas first, and then write that as a ratio, and then simplify that ratio. Okay, so we can just, for A, we can just count the squares, can't we? Because, well, they're easy, we can see. So I've got like 2 rows, 2 columns, 1, 2, 3, 4, 5. So I'm just dividing this shape up like this into 2 rectangles. So this is 2 by 1, 2, 3, 4, 5, 6, 7, 8. 2 times 8, which is 16 squares in there. And I've got another 2 by 1, 2, 3, 4. 2 times 4, which is 8, giving me a total area for A of 16 plus 8, which is 24. So it's 24 to what? Okay, let's have a look at our shape B now. Now, shape B is a triangle. I can't just count squares in this case because I've got lots of part squares. It's going to be easier to use the area of a triangle formula, which is half base times height, isn't it? Half base times height. Okay, which is a half of what? What's the base? Well, I've got 1, 2, 3, 4. It's 4 units along there. So it's half of 4 times the height, which is 1, 2, 3. So height 3. So half of 4 times 3, which, well, 4 3s are 12, divided by 2 is 6. Okay, so the area of shape B is 6 units. So that gives me a ratio of 24 to 6. Now, you can cancel down ratios very much the same way as doing fractions. You just need to find a common divisor. I know my 6 times table, and I recognize that 6 and 24 go into 6 and both in the 6 times table. So if I divide both numbers by 6, 24 divided by 6 is 4, isn't it? Goes in 4 times, and 6 goes into 6 once. So it gives me the ratio of 4 to 1. Now you have to get that the right way around. It isn't 1 to 4. We need to start with shape A and then have shape B afterwards. So it can only go that one way round. Question 14. Work out 258% of 6,300. Now I tend to use a little triangle, final, original, multiplier to work out percentages. If you're interested to know how I do that, you can perhaps watch my video here. It goes into a bit more detail about it. I'll put a link up now for that one. So anyway, I'm going to work out what F, O, and M is. So final, original, multiplier. So the final is what I'm going to work out after I've done my percentage change. The original is what I've got starting with, which is 6,300. And the multiplier is that percentage written as a decimal. So 258% as a decimal is 2.58. So what I do now is I cover up the thing that I want to find. So I put my thumb on top of F, and then it tells me that final is equal to original multiplied by multiplier. So the formula is final equals original times multiplier. Original is 6,300 and multiplier is 2.58. So reaching for a calculator, 6300 times 2.58 gives me 16,254. Okay. Like I say, if you want more help with percentages, check out my video on percentages. You're given that A is equal to 3 and B is equal to 5. Tick whether each statement is true or false. Give a reason for each answer. Okay, so statement 1 says AB equals 35. Well, that isn't true because AB means A times B, which is 3 times 5. So the answer is 15. So A times B is equal to 3 times 5, which is equal to 15. So that's why it's false. 2b squared is equal to 100. So 2 lots of b, we're saying b is 5, yeah? So 2 lots of 5 all squared, what's that equal to? Remember BIDMAS says do the indices first. That's 2 times 25 then, and 2 times 25 is 50. So again, that is false. Question 16. The pie chart shows some information about the share of votes for candidates in an election. And we're told that it's not drawn accurately. Okay. Now it says the angle for Mrs. Wood would be 24 more than the angle for Mrs. Patel. There are 5,220 votes in total. Work out the number of votes for Mrs. Patel. Okay, so we don't know what Mrs. Wood got, but we know that it's 24 more than Mrs. Patel, but we don't know what Mrs. Patel had. So let's say that Mrs. Patel has X votes. Then Mrs. Wood is going to have 24 more than that, so she's going to get X plus 24. Okay, and so all of those added together is going to give me 360 degrees, which is the total number of angles in a circle. So I can write that down then. So my 64 plus my X plus 24 must be equal to 360 degrees. Okay, so then collecting like terms, I've got a number 64 and 24, and I've got an X and an X. So adding like with like, so 64 and 24 gives me 88, plus 2x is equal to 360 degrees. Okay, so subtracting 88 from both sides, that's going to leave me with 2x is equal to 360 subtract 88. Just going to do that on my calculator. No point in risking making an error. So that's 272. And then to find x, I'm going to have to divide by 2 then, aren't I? Divide by 2, divide by 2. So then x is going to be 272 divided by 2, 136. That means that angle there is 136 degrees, and then Mrs. Woods is going to be 24 more than that then. That's going to be 136, 140, 160 then, isn't it? Hers is 160 degrees. What do we need to do now? We need to work out the number of votes for Mrs. Patel. Okay, so we know that Mrs. Patel's angle is 136. So her fraction of the vote is going to be 136 out of 360 times the total number of votes. So we can use 136, 360, it's like a fraction. So we work out that fraction of the total. So what is 136 360ths of 5,220? Okay, we can just tap that into the calculator using the fraction key. So using the fraction key, 136 over 360 multiplied by 5220 gives me a total of 1,972. Okay, so Mrs. Patel must have got 1,972 votes. Question 17. White paint and red paint are mixed together in the ratio of 2 to 3. Draw a graph that can be used to work out the amount of red paint needed given to the amount of white paint. Your graph must show up to 10 litres of white paint. Ooh, okay, so I've got red paint on the y-axis and white paint on the x-axis. And I know that the ratio is 2 to 3 of white to red. So white to red is in the ratio of 2 to 3. That means for every 2 units of white paint, we need 3 units of red. So we can use this kind of like a gradient. So starting at the origin, for every 2 units we go along in the direction of white, we're going to go 3 units up in the direction of x, which gives me a point there at 2. Well, it's going to be 3, isn't it? So if I add another scale on, 3, 2, 1. So let's just put the rest of those numbers in. 4, 5, 6, 7, 8, 9. It's going to go a bit higher than the other one because it's a ratio of 3 to 2. I think we need to go up to about 15, 12, 13, 14. Just fits. 15. So 2 along, 3 up, and we just keep going and doing more of those then. So every 2 we go along, we go 3 up. 2 along, 3 up. 2 along, 3 up, 2 along, 3 up, 2 along, 3 up. Okay, and that will give us a straight line through the origin, stretching all the way up. So I'm just going to shrink that down so you can see the whole thing. Right, then using a ruler, I'm going to join those points up, so through the origin and then through each of those points. Okay. There we go. Oops. I think that's just about okay. Right, now, how much red paint then needs to be mixed with 9 litres of white paint? Okay, so now we can use this as a lookup value then, can't I? So I can use the scale. Let's just stick that down a bit so you can see it all. So I can find 9 on my axis here. Read up. It's still going off the top. So find 9, read up to the line, and then read across and use that as an estimate. Okay. So going up till I get to the line and then changing direction. I'm going across. Okay, so that comes out on mine to be 13 point. I've got 3 little squares out of 5. So each one of these little squares is going to be 0.2, isn't it? 13.246. So that's going to be 13.6 litres of red. 13.6. Now, checking the mark scheme, it says in there that the actual answer given is 13.5. So you can see mine is slightly out, but that's because of how I drew the line here. The computer ruler wasn't quite as handy, and I haven't quite gone through the origin down there. But it's close enough, and I think you would still get the full marks if you're like a half a square out. So it's no problem. It'd still be marked correct. Question 18. The perimeter of an isosceles triangle is 25 centimeters. The length of each side in centimeters is a prime number. Work out the lengths of the sides of the 2 possible isosceles triangles. So notice that 2 is in bold. That's normally something that students will otherwise miss. So there are 2 possible solutions, and we need to find both of them. Now, what does an isosceles triangle look like? It is a triangle where 2 sides are equal, so that one is equal to that one. Okay, and we're told that the length of each side is a prime number. Okay, so they're all primes, and obviously 2 of those numbers are going to be the same, and they add up to 25. So if this one was x, this one would also be x, and this one could be a different number. It could be y. And my 2 x's together plus my y is going to give me my total of 25. We need to then guess which prime numbers they might be. Okay, so it might be helpful to list some of the prime numbers out up to, well, let's go up to 25. It's probably overkill, but let's do it anyway. So prime numbers are less than 25. Prime numbers. Well, the first prime number is 2, isn't it? It's the only even prime number. And then we've got 3, 5, 7, not 9, 11, 13, not 15, 17, 19, not 21, 23 is one though, isn't it? Okay, so we need to find 2 primes that fits this triangle then. So if it was 2, I'm just going to do a bit of trial and error until I find ones that work. So I'm going to go through the list. I'm going to imagine it here. So if I put the 2 here, then that's 2 and 2, which gives me 4. Then 4 taken away from 25 leaves me 21, and 21 isn't on my list of prime numbers, so it can't be 2 and 2 there. I'm just going to proceed through and keep doing that. So if I put 3 and 3 here, that gives me 6. 25 subtract 6 is 19, and 19 is on my list, so that is a possibility. So it could be 3, 3, 19. So we found one of them. Let's carry on. So next choice, let's make it 5 and 5. 5 and 5 makes 10. 10 take away from 25 gives me 15. That's not a prime number, so that doesn't fit. So let's try the next prime number, which is 7. So 7 and 7 make 14. 14 take away from 25 leaves me with 11, and 11 is on my list of primes. So that one does work. So 7, 7, 11 then, wasn't it? Okay, now I don't really need to check anymore because we're told that there are 2 possible ones and I've already found 2. So I'm just going to stop there. So 3, 3, 19 and 7, 7, 11. So 3, 3, 19 and 7, 7, 11 are my 2 possible answers. Question 19. A children's nursery uses 1 room for babies and 1 room for toddlers. Okay, so we've got room A, which has got an area of 40 meters squared, and room B, which has got an area of 37 meters squared. It says each baby needs at least 3.5 meters squared of floor space, and each toddler needs 2.5 meters squared of floor space. Okay, so what's the question? Isn't one yet. Well, we have to wait until the other side of the paper to learn what the question is. So, show that the total number of children allowed is larger if the toddlers are in room A and the babies are in room B. Okay, so we need to show that one is larger than the other. So we need to work it both ways around, basically, don't we? So we need to work out how many toddlers we can fit into room A and babies in B, and then compare that to the other way around and work out what the total is. Okay? So if I've got room A and room B, if I put toddlers in room A and babies in room B, then I'm going to need to divide the total for room A, 40. I'm going to have to divide it by 2.5, the space for each toddler. And for room B, I'm going to have to take the total area of 37 and divide it by the space for babies, which is 3.5. Work out what that is, and then compare it. So what's 40 divided by 2.5? 40 divided by 2.5 gives me 16 toddlers I can fit into room A, and 37.35. So 37 divided by 3.5. That's 10 and a fraction. It was 10 and a bit, isn't it? Now, you can't put 10 and a bit babies in the room. There are laws against that sort of thing. So you have to round this off. Now 10.57 actually rounds up to 11, but that would be squeezing an extra baby into this room and not giving them an appropriate amount of space. So we're going to have to round this one down to 10, okay, and not 11. So I've got 16 toddlers and 10 babies, give me a total of 16 plus 10, which is 26. Okay, so let's try doing it the other way around now. So that was toddlers and babies. So let's try it the other way around. So if I put babies here and toddlers on this side, this time I'm going to be dividing 40 by 3.5, and I'm going to be dividing 37 by 2.5. The other way around, aren't we? Okay, so again, reaching for the calculator. 40 divided by 3.5 gives me, again, it's a fraction, 11.4. Again, I can't divide babies up like that. That's not nice. So I'm going to have to round it down to 11. And 37 divided by 2.5 is 14.8. Again, you can't really divide up toddlers. They don't like it. So I'm going to round that down to 14. So I've got 11 babies and 14 toddlers. So the total for babies and toddlers is going to be 11 plus 14, which gives me 25 children altogether. So you can see for that way round, the first way round, I had a total of 26, and the other way around, the total was 25. So I can fit more children in if I put the toddlers in room A. So more children if toddlers are in room A. Find the next term in a quadratic sequence. Now, quadratic sequences don't go up in even jumps like linear ones. This one between 4 and 12 is plus 8, between 12 and 24 is plus 12, and between 24 and 40 is plus 16. So they're not going up in equal jumps, but you can see that there's a pattern in how they are increasing. Plus 8 plus 12 plus 16, and the next one is going to increase by plus 20. So 40 plus 20 is 60. To circle the inequalities shown in this diagram. So we've got this line that stretches from -7 up to 6. Now the value of x is going to lie somewhere in between these. Now we just need to work out which way around the signs go. Now underneath the -7 we have a filled dot, and the filled dot means that the number -7 is included in the range. So we're going to draw a greater than or equal to symbol between those two. So x is greater than or equal to -7. At the other end of the scale we have an open circle. That indicates that number 6 is not included in the range. So we need to include a symbol like that. So x is strictly less than equal to 6. So our answer is going to be this one. Water is poured into a glass for 4 seconds. The graph shows the depth of the water in the glass. So we can see as time increases from 0 to 4, the depth is increasing steadily. And we need to work out the rate of change of the depth of the water. Now, rate of change is the same thing as gradient, so we need to basically work out what the gradient of the straight line is. Now, to work out the gradient of a straight line, we need to select 2 points on the graph, on the straight line, and we need to work out what the change in y is, and divide that by the change in x. So the change in y here is the difference between 10 and 0, so that's 10 that way, and from 0 to 4 that way is 4. So rate of change is the gradient, and that's equal to 10 divided by 4, which is 2.5. That one. Okay, Ali is going to throw a dice 6 times, and he says, I will get one of each number. Give a reason why he could be wrong. Well, getting one of each number is just one of many different possibilities, actually. And in any case, actual outcomes don't necessarily match theoretical values. So that's what I'm going to write down. Actual results don't always match theoretical probabilities. Okay, part B says Lucy throws a dice 50 times, and here are her results below. So you can see that she's got a frequency table of the number of times each number came up top. We're asked to work out the relative frequency of throwing an odd number. Now, relative frequency is equal to successful trials divided by total trials. Okay. In this case, there were 50 trials in total. It told us that in the question. And we want to work out how many successful trials there were. Well, in this case, success is throw in an odd number, of which there were 7 ones, 12 threes, and 9 fives. So adding those 3 numbers together, 7 plus 12 plus 9, which is 28. So that is 28 out of 50. Now I could cancel that down, but often in these sorts of questions you don't actually get any extra credit for cancelling down probabilities, and there is a danger that when you cancel them down you make a mistake. So the only possible outcome of you cancelling down a question like this is you losing marks, so don't bother. Shows a polygon ABCDE, and that has been divided into 3 triangles, and we need to use the triangles to work out the sum of the interior angles of a polygon ABCDE, and we must show our working. Well, this polygon has got 5 sides, so it's actually a pentagon. So a 5-sided shape has got 3 triangles that go inside. Your maths teacher might have shown you how to derive the formulas for sum of interior angles of a polygon, and they do involve just dividing the shape up like this into triangles. You know that the angles inside the triangle sum to 180 degrees, so this triangle here adds up to 180 degrees. Now the triangle next to it also adds up to 180 degrees, its interior angles there. And finally our last triangle adds up to 180 degrees too. So you can see that those 3 angles there form that interior angle of my pentagon. And then I've got another one there, look, and another one there, another one there, and another one there. So the 3 sets of 180 degrees from my triangle add up to the interior angles of my pentagon. So let's write that down below. What are we going to write? Angles in a triangle sum to 180 degrees. So interior angle of ABCDE equals 3 times 180, which is 540 degrees. Okay, we're given the graph of a quadratic curve, and we're also given a partial formula. This one up here, y equals a plus bx minus x squared. So it's a partial formula because we haven't yet been given the values of a and b, these coefficients here. And I imagine during the course of the question we're going to have to work out what those are. Okay, so let's have a quick look at what the questions are asking us to do. A says circle the coordinates of the turning point of the curve. So the turning point of a quadratic curve is going to be its highest or lowest point. Oops. Which is going to be this point here. That's got coordinates 2, 16. So circle the coordinates of the turning point of the curve. Well, 2, 16. Next, asked to circle the value of a. Now, coming back to our partial formula or equation for the curve, y equals a plus bx minus x squared. Now a is the constant. In other words, it's the y-intercept of this graph. So we can find a by looking at where the curve meets the y-axis, which is this point here. So that's going to be our value for a. It's not what we normally have as y equals mx plus c when we're looking at straight line graphs. So normally we use the letter c for this. But here they've labelled it a, so that is going to be the coordinates of a there. So that's the coordinates 0, 12. Circle the value of a. It's going to be 12. That's the y-intercept. Okay. Next part of the question, circle the two roots of the equation. Now the roots are where the curve cuts the x-axis. So we can see that the curve meets the x-axis here and here, which is at minus 2, 0 and 6, 0. So let's answer the question now. So the roots are minus 2 and 6. We're told that a school has 60% of their students being girls, and of those, 50% of the girls walk to school and 20% of the boys walk to school. What is the percentage of students who walk to school? Now, first thing to note in this question that there's no number of students given. So we're just working purely with percentages. If it makes it easy for you to think about, then you can just assume that there are 100 students. So assume 100 students. Okay. Now I'm going to try and collect all this information in a two-way table because we've got two quantities. We've got boys, girls, walk to school, doesn't walk to school. So I'm going to make a two-way table. A bit like this. So this is going to be my boys, girls, walk to school, doesn't walk to school. Now I know that altogether we've assumed there are 100 students. I'm going to write that down there in the bottom right corner. Now we are told that 60% of the students are girls. So that means the total number of students that are girls are 60. And that means there must be 40 boys or 40% boys. Now, next we're told that 50% of the girls walk to school. 50% of the girls walk to school. So there are 60 girls altogether. So 50% or half of them walk. So that's going to be 30 there. So if 30 walk and there are 60 altogether, 30 don't walk. Okay, and then for the boys, 20% of the boys walk to school. So we decided there were 40 boys. 10% of 40 is 4, so 20% is 8. So we're going to have an 8 there. So that makes this one 32. Okay, so adding up along the columns now, I know that 38 out of 100 walk and 62 out of 100 don't walk. So what percentage of students walk to school? It's going to be 38 out of 100 or 38%. Now the secret of exam success is to be able to correctly decode the command words the examiner is asking of you. So you've got two words here, factorise fully. Now factorise is math speak for putting brackets in, and fully is, well, it's just signposts that there are more than one factor to find. So if you ever see the word factorise fully, it means that there are more than one factor to find. So here, if I've got 9a squared and 6a, when I factorise, I'm looking for common factors between those two terms. So clearly, both of them have an a in them. So I've got an a here and an a here. So they have an a in common. But the number part as well, the 9 and the 6 are both in the 3 times table, so I have a second factor of a 3. So I'm going to take out the common factors and put it at the front. So 3 is common because it goes into 9 and 6. And a is common because it goes into a and a squared. And then I open a pair of brackets, and then inside the brackets are the bits that aren't in common between the two terms. What do I need to multiply with 3a to get 9a squared? Well, 3 times 3 is 9, and a times a is a squared, so I've got to have a 3a there. And I'm going to have a minus sign in the middle to match that one in the expression. And then I have to work out 3a times what is 6a. Well, 3a times 2 is 6a. Okay, that's the answer. So I factorised it by putting brackets in, and I factorised it fully because I've got both the common factors out. Question 27b. Solve x squared minus 12x plus 20 is equal to 0. Okay, so we've got a quadratic equation in x here. It's set equal to 0. Now, in order to solve these, as it's asking, you need to first factorise it into two brackets like this, and then equate each bracket to 0 and find out what the value of x makes that true. Okay, so we need to factorise it first. Now, we need to come up with well, we've got x squared to start with at the start here, haven't we? So to get x squared, I'm going to have an x and an x here. Now the next thing to look at is this positive 20 at the end. That tells me my two numbers multiplied together to give me 20, but they add together to give us this number in the middle, which is minus 12. So it multiplies to give me a positive number, and it adds up to give me a negative number. Now that tells me that both of these signs are negative, because a negative times a negative is a positive, but when I add two negative numbers together, I'm going to get a negative number. Okay, now the next step is to work out what are the factor pairs of 20, this number here. Okay, so the number 20, well, we've got 20 and 1 multiplied together to give you 20, or we could have 10 and 2, 10 times 2 is 20, or we could have 5 and 4. 5 times 4 is 20. Now these are all going to be negative numbers, because we already know there's going to be two negatives. And now which pair is going to add up together to give us negative 12? It's going to be that one there, isn't it? So it's going to be x minus 10, x minus 2. So the negative 10 times the negative 2 is going to give me the positive 20, and the negative 10 plus the negative 2 is going to give me negative 12 in the middle. Okay, so if I've got two things multiplied together to be, and that equals 0, we know that one of the things must be 0 to start with. So either x minus 10 is equal to 0, which means x is equal to 10, or we know that x minus 2 is equal to 0, in which case x is equal to 2. So then the answer is x equals 10 or x equals 2. Two solutions. We're told that Adam and 6 other men ran a race. The times in seconds of the 6 other men are shown. The mean time for all 7 men was 9.83 seconds. Did Adam win the race? You must show your working. Okay, so we've got the times for the 6 men that Adam raced against, but we don't actually have Adam's time. So let's use a bit of algebra and call Adam's time x to start with. So we would calculate the mean by adding all 7 values together and then divide by 7. So x, Adam's value, plus all the other gents, 9.79, 9.80, 9.88, 9.94 and 9.98, all divided by 7 because there were 7 runners, and we know that that is equal to 9.83. Okay, I think it's time to reach for a calculator. I'm going to cross multiply that up there, so getting rid of the 7 on the bottom, 7 times 9.83, that is equal to, so 9.83 times 7, 68.81. So I'm going to write 68.81 this side, And then on the other side, I've got x plus all those other 6 gents times. I'm going to quickly add those up. 9.75 plus 9.79 plus 9.8 plus 9.88, 9.94 and 9.98, which comes to 59.14. 59.14. Okay, so now we just need to solve for x, taking my 59.14 to the other side and subtracting from my other value. So 68.81 minus answer 9.67. So did he win the race? Yes, because his time is faster than everybody else's. So I can answer yes. Adam ran the fastest time, so won the race. Shows a square whose sides have been given algebraically, and we need to work out the length of one side of the square. Now these questions that mix geometry and algebra are becoming more and more common, so expect to have one a bit like this in your exam. So we know it's a square, so those two sides should be equal to each other. So I can equate them in an equation. So I can write down one side of my square, 6x minus 3, must be equal to the other side of the square, 3x plus 1. So actually all I need to do here really is solve for x. I've got a linear equation in x that I need to solve. So let's just remove the brackets on the right hand side first. So that gives me 3x plus 3 over there. Then let's collect all the x terms on one side and the number terms on the other, which will give me 7x minus 3x is equal to 3 plus 3. 7x minus 3x is 4x. 3 plus 3 is 6, giving me x is 6 over 4, which is the same thing as 3 over 2. Okay, done. Or are we? Just make sure at the end of every question you reread it, because I almost missed this. Work out the length of one side of the square. Sometimes when we find x we think, oh yeah, our job is done, but back to our square, our squares are not of side x. I've got one which is 7x minus 3 and one which is 3 lots of x plus 1. We worked out the value of x, so we haven't worked out the side of the square yet. We can use either one of those, so I'm going to use the 3 lots of x plus 1 because it looks slightly easier. So what's 3, what is 3 lots of, so when x equals 3 over 2, then 3 lots of x plus 1 is 3 lots of 3 over 2 plus 1. So 3 over 2 plus 1 is 5 over 2 times 3 is 15 over 2, which is 7.5. Question 30. In the diagram, DC is parallel to AB. So DC is this line here, AB is this line here, and you can see that they are parallel. Okay, so I've got a pair of parallel lines. It's not a parallelogram. Looks a bit like one, but those other two lines are not parallel. Now it asks me here to show that the triangle ABD is isosceles. So where's ABD? ABD is ABD, this triangle here, that's the triangle I'm looking for. And I need to show that it's isosceles. In other words, I need to either show that the lengths of two sides are equal. I'm not going to be able to do that. Or I can show that this angle and this angle here must be equal to each other. Okay, so I know the angle at the top is 124, so I need to show that this angle here then and this angle here are going to be isosceles. Are going to be equal to each other and therefore isosceles. Okay, so how am I going to do that? Well, let's have a look at the other triangle first, the triangle BCD, which is, I'm making a bit of a mess of this diagram. It's this triangle over here, look. Okay, so the blue triangle, I know 2 out of 3 of the angles from the blue one. I've got 152. So the angle at the top there, this angle up here, is going to be, well, the angles in the triangle add up to 180 degrees, don't they? So my 100 plus my 52 plus my angle there equals that angle there, doesn't it? So I know that that angle is equal to 180 minus the other 2. So it's going to be 100 plus 52. 100 plus 52 is 152. So 180 minus 152, what's that equal to? So 180 minus 52 is 180 minus 150 is 30, and 30 subtract 2 is 28. So that angle there is 28 degrees. Okay, so I know that one's 28. How's that helping me? Well, when you've got a pair of parallel lines and a line crossing them, then the angle there and the angle there we call alternate, don't we? And we know that alternate angles are equal. So that angle is going to be the same as that one down there. So on this diagram, that 28 is going to be the same as this angle down here then, isn't it? That one there is 28 because they're alternate. So I now know that that angle there must be 100, that is 28. So then this angle up here then, again, is going to be 180 subtract the other 2. So 180 subtract 124 plus 28. So 124 plus 28 is what? 124, 144, 152, isn't it? 180 minus 152. Oh, look, that's equal to 28 as well. That's also equal to 28. Okay, so we've shown then that both angles are 28 and therefore is isosceles. So we can say that angle ADB is equal to angle ABD, and that's equal to 28 degrees. So triangle is isosceles. Okay, done. Well, that's the end of the paper. Not too bad, I hope. Let me know how you did in the comments, and if you have any unanswered questions, why not ask them below. If you didn't do so well, time to hit the books a bit more and then come back and try another past paper in a few days. I'll be here to help you through that one too. And if you haven't already done so, why not subscribe so you can find me again for the next practice paper. Work hard, keep trying your best, and you will make progress. See you again next time.